Breaking news. At 02:19 UTC this morning, observatories across 3 continents detected an event that no one was prepared to explain. An interstellar object, already classified as anomalous, suddenly produced a high-energy jet pointing backward, directly opposite its direction of travel. The signal was first flagged by automated systems at the Atacama Large Millimeter Array in Chile, then independently confirmed minutes later by infrared instruments aboard the James Webb Space Telescope. Within seconds, alerts rippled through NASA, ESA, and multiple university observatories. Today, the impossible just happened. An object moving at interstellar velocity violated one of the most basic expectations of physics. This changes everything we thought we knew. And if you want to stay updated as this cosmic mystery unfolds, now is the moment to like, subscribe, and stay with us, because this story is far from over. The confirmation came fast, and it came hard. Within the first 10 minutes, spectroscopic data from Hawaii's Mauna Kea Observatory showed a sharp spike in ionized carbon and molecular nitrogen, signatures consistent with jet activity, but oriented in a direction that made no sense. In every known comet, jet emissions trail away from the sun, driven by sublimating ices and solar radiation pressure. But 3I Atlas was doing the opposite. Its jet was firing into its own path, as if braking, or worse, steering. By the time European Space Network antennas locked on from stations in Spain and Australia, there was no longer any doubt. This was not a sensor glitch. This was not noise. This was real. To understand why this moment is so disruptive, we need to establish authority and context. 3I Atlas has been under continuous observation since its detection, with data pooled from NASA's Jet Propulsion Laboratory, ESA's Planetary Defense Office, and academic teams from Harvard and Caltech. Hubble had already tracked subtle non-gravitational acceleration. JWST provided unprecedented thermal resolution, measuring surface temperatures fluctuating between 180 and 310 Kelvin, far too variable for a simple inert rock. Radio observations from the Atacama Array revealed periodic emissions in the millimeter band. And now, this, a backward jet, observed simultaneously from South America, North America, and Europe. 3 continents, 5 instruments, 1 conclusion. Whatever 3I Atlas is doing, it is not behaving like any natural object we have ever catalogued. 48 hours before the event, everything appeared stable. Orbital Solutions placed 3I Atlas at 2.37 astronomical units from the Sun, traveling at 32.4 kilometers per second relative to the solar barycenter. Its trajectory was hyperbolic, confirming its interstellar origin. 11 hours later, subtle deviations began to appear. Tracking data from Goldstone showed a lateral drift of 0.0004 meters per second squared, small but statistically impossible to ignore. 6 hours after that, thermal imaging detected a localized hotspot forming on the object's trailing hemisphere, not the sunward side, the opposite side. At the time, it was logged as an anomaly. In hindsight, it was a warning. At T-2 hours, the hotspot intensified. Temperatures spiked to 480 Kelvin in a region less than 200 meters across. No known cometary process could isolate heat with that level of precision. Then, at the moment now etched into every astronomer's memory, the jet appeared. A narrow, highly collimated stream of ionized gas extending nearly 14 kilometers into space. Emission velocity, 1.9 kilometers per second. Direction, directly against the object's velocity vector. The result was immediate. 3I Atlas slowed, not dramatically, but measurably. A deceleration of 0.8%. In space, at that scale, that is enormous. Physics does not like this. Every known model of jet formation relies on external heating, usually solar radiation, driving material away from the surface. That process cannot produce thrust opposite the direction of motion without an internal energy source. Spectral analysis deepened the mystery. The jet contained excited nitrogen compounds, traces of xenon, and a faint but unmistakable signature of ionized silicon. These are not common in cometary plumes. More troubling was the symmetry. The jet's emission profile pulsed at regular intervals, every 11.3 seconds, perfectly timed, perfectly stable. Within hours, emergency meetings were convened. At Caltech, Dr. Elena Kovacs ran rapid computational simulations, feeding the jet parameters into every known natural model. None fit. At Harvard, Dr. Marcus Levin compared the pulse intervals against known astrophysical phenomena. No match. Meanwhile, gravitational modeling teams at NASA noticed something else. The jet was not just slowing 3I Atlas, it was subtly adjusting its trajectory by 0.12 degrees. That adjustment aligned the object closer to the ecliptic plane, closer to the inner solar system. The first hypothesis emerged quickly. The mainstream explanation? An exotic but natural process. A pocket of volatile super-ices, perhaps, trapped beneath an insulating crust since the object's formation around another star. When exposed to solar radiation, the pocket ruptured, releasing energy in an unusual configuration. It was rare, scientists argued, but not impossible. The backward orientation could be explained by irregular rotation combined with localized structural weakness. This explanation was safe, comfortable. It preserved physics as we know it, but it did not survive contact with the data. Because 12 hours later, the jet shut off. Abruptly. No tapering, no decay curve. And when it did, the object stabilized, holding its new trajectory with uncanny precision. Then came the second wave of anomalies. Radio telescopes in Australia detected a low-frequency emission at 1.42 gigahertz, the hydrogen line, but modulated. The signal repeated in a sequence: 2 pulses, pause, 3 pulses, pause, 5 pulses. Prime numbers. This was no longer random. It was responding. A fragment appeared, or rather, separated. A small mass, approximately 1.6% of the original object, detached silently from the main body. No explosion, no debris field. It simply moved away. Both pieces maintained synchronized jet pulses for exactly 94 seconds. Then, the fragment vanished. Every sensor lost it simultaneously. Infrared, optical, radar. Gone. Inside control rooms, the mood shifted from confusion to something colder. Internal communications, later leaked, showed scientists arguing in hushed tones about protocol. Should this be disclosed? Should trajectories be recalculated with planetary defense models? ESA issued a brief statement calling the event under investigation. NASA went silent for 6 hours. That silence spoke volumes. On Earth, subtle effects began to register. A cluster of low Earth orbit satellites experienced temporary attitude control failures. Radio operators reported brief blackouts in the VHF band. Magnetometers in northern Canada recorded fluctuations of 12 nanotesla, small but synchronized with the jet pulses. Even biological systems seemed to notice. Ornithologists reported unusual shifts in migratory bird patterns, deviating by several degrees during the same window. In the quiet moments between data uploads, reflection crept in. I remember staring at the feed, watching the numbers scroll, and realizing that we were no longer asking what 3I Atlas was. We were asking why. The universe has always spoken to us through forces: gravity, light, time. But this felt different, deliberate, controlled. Maybe we're not witnessing the end of certainty, but the beginning of a conversation. As of now, 3I Atlas continues inward, slower than before, quieter, but not inactive. Its last recorded emission was a single pulse, precisely timed, then silence. What happens when it fires again? What happens when it doesn't? Subscribe to follow the next update. This story isn't over.